Okay, so now we're going to talk about a new kind of infinity, which is all real numbers. Okay. And this, the idea that this was a different infinity was I'm going to say discovered by Georg Cantor I think in the late 1800s. So he said, do this. Just take all numbers, all real numbers between 0 and 1. Okay. So this includes fractions.
Yeah.
It includes
decimals.
All decimals. We're going to write them as decimals. And all numbers like, well, since we're going to go between 0 and 1, like something like square root of 2 over 2, or like pi over 4, things like that, that can't be written as fractions. Okay?
Mm-hmm. Yeah.
So he said, let's say you made a list, and then you have the first one on the list, the second one on the list, third one on the list, fourth one on the list. Let's say this was 0.34297, etc. This was 0.1291445. You tell me this number.
It could be 0.281702.
Okay, how about this number? You tell me.
0.503024.
Okay. And he said, now, and your list goes on forever, and you say, you know what? What I've done is I've written down all the numbers between 0 and 1. And he said, you can never do that, because you're always going to have a number that's not on the list.
Yeah.
Okay, and here's why. He said, look at the first digit of the first number, the second digit of the second number, the third digit of the third number, the fourth digit of the fourth number. And what we're going to do is we're going to make a new number. Okay? So we're going to go down this diagonal. First digit of the first, second of the second, third of the third, fourth of the fourth. So the 100th number, what are we going to look at?
The 100th digit
The
of
100th
100.
digit.
Mm-hmm.
And the rule is going to be, if that is 1, make it 7. And if it's not 1, make it 1. Okay, so we got a new number. 0. Well, is this number 1?
No.
So what do we make it?
7. Or not 7. 1.
Wait, make it 1.
We make it 1. What about this number?
That one that's not 1, so we make it 1.
1.
If it is 1, then we
Make it 7. Then it's not 1, so we make it 1.
Okay, we just keep going on down the list. Now, can this number have been on our list before, the number we're making?
Well, if you could say it, if it was on our list, then well, if it was, you could do that. You could do it again.
Well, could it be the first number on our list?
Well, no, the first number on our list is 0, a bunch of zeros followed by a 1. If you want to write them in order.
How did we write them? What order did we write them in?
Well, we didn't really write them in any order.
Right. So we had this, and we said this list that we have is all the numbers. Okay.
Alright. And we made this new number.
And we made this new number. And how did we make it?
So we took the first digit of the first, the second of the second, the third of the third, the fourth of the fourth.
Mm-hmm.
And then we keep doing that.
And then we applied, if it's not 1, make it 1, and if it's 1, make it 7.
Okay. So, and now we're looking at this number that we made by doing that. 0.1171, so however it goes on. Could this number have been the very first number on our list?
No,
Why not?
because, well, first number, this doesn't have any 1s in it, this first number, from what we read. There's the first, you can see from here that it's not.
Yeah, but tell me why.
Well,
How do I know?
1 isn't the first digit.
Aha! Could it be the second number on our list? Could our new number be the second number on our list?
1 isn't the second digit.
Ah. What about the third number? Could it be the third number on our list?
Well, 7 isn't the third digit.
Okay, so how do we know that this number is not on our list?
Because we changed the numbers around.
Yeah, because even if this part matches up, the part before the number we selected, the number we selected won't match up.
Because we made sure it doesn't.
We made sure that this number differs from every number on our list in at least one digit. So it couldn't have been on our list before.
So that's a number we missed.
It's a number we missed. But now I could just say, okay, well, let's add this to our list. And then I can go through the process
Then you can
again.
do, yeah. You
So-
can do it again.
You can do it again. So any list you have, any countably infinite list of numbers that you have, is going to miss a number. And that means there must be
More.
a new infinity. And you know what this infinity is called?
What?
Uncountable.
Uncountable.
Uncountable. So with that introduction, we're going to start talking about two new sets in topology. Okay?
All right.